Engaging the hard lock will be able to cycle through our targeted actors. The actors will be updated every time we cycle, so we'll only get the actors within the viewport. If our hard locked actor is off the screen and we try to cycle, we'll either be able to keep the target locked or move to the next nearest actor. And finally, if there's only one actor on the screen, we won't be able to cycle until there's another enemy within view.
Back in our third-person character, off to the right of everything we've done so far, I'm going to get a keyboard event. And I'm going to bind it to tab. And when we tab, we want to make sure that we only do this if we have a selected target and our target is locked. We should just be able to call a target locked, but it's always good to check to make sure that we have a valid target to tab from. So under selected target, we're going to convert this to a validated get. Then we're going to get a branch and check the condition against our target being locked. Now the idea here is that we're going to be taking our index of targeted actors and we're going to be manually looping through them. But we want to make sure that our targetable actors is always updated. So when we press tab, we're going to get our soft lock start because we want to update the array every time we press tab. But we only want to do it once because this is technically going to be only working if we have the target lock, so we don't need to actually start the soft lock. This is just to get a current list of our targeted actors every time we press it. And then because we only want to target another actor that is on screen, if we only have one actor on the screen, we want to basically ignore the input. So we'll get a branch. And our targeted actors, we're going to get its length, which is just how many actors are in the array. We want to make sure that our length is greater than 1. Then we're going to make a new custom event. And we'll just call this cycle target. And at the end of our true, we'll call cycle target. And now we can begin manually looping through everything. So first we get a branch, and we need to check against an index for our target actor. So we're going to make a new variable, and we're just going to call it index. And its type is going to be integer. By default, we can leave the index at 0. And we're going to check to see if the index is less than the length of our targeted actors. Because when we cycle through this, if we get to the end of our length, and if we go on to the next index, it's going to give us a null error because there's nothing there. So if we do reach the end of the index, we want to set the index back to 0 from our false pin, and then we want to call cycle target again. So if we tab through 2 different actors of our index of 0, we'll go on to the true condition, whatever that may be. Then we get to the end of the array, and then we set it to be 0, and then we filter through this again. Off of our true, we want to turn the hard lock widget off of our selected target, should it be on. We drag in our selected target and get the hard lock widget. And set it to be hidden. And now because this array can get very messy and we aren't going to necessarily know what position we are in the array after using it a couple times and actors are coming in and actors are coming out, we need to get another branch to make sure that our selected target is the target that is in the index. We get a branch. And we're going to drag in our selected target. Type in equal equal. And we're going to make sure that our target is in our array. So drag in our targeted actors array, hit get. And our index is going to be the index. So now it checks against the current index. If we are currently on our selected target when we try to tab to the next index, meaning it's essentially going to do nothing since our targeted actor is already being targeted, off of true, we're going to increment the index. So we can just drag in the index and type in ++, which will automatically just add 1 to our index value. Otherwise, if it's not the targeted index, we want to set the selected target to what is currently in the index of our targeted actors. So we can get our selected target and set it on false. And it's essentially just this get right here. So now we select a new target. And because we turned the hard lock off, we can copy that and turn it back on. And then we want to increment the array. So if the targeted actor in this index is the last actor of the array, if we increment this to 1 beyond the array, we're going to get an error if we try to press this again. So we'll get a branch. We're effectively checking this again. Our first condition. And the reason why we're checking this rather than just having this call cycle target again is because we need to set the target before we call it again. Otherwise, it's just going to repeat and we're going to get stuck in an infinite loop until we get back to our selected target again. So we don't want to do that. We still want to get the index of our current target and set our selected target. Off of false, we can just set the index to be 0. Because again, if we're at the end of the array, we wanted to set this to be the first target in the array. So effectively, we loop over the end back to the beginning this way. And then just as we set the hard lock to be visible, we're going to copy that and place it at the end. Now this should loop through the array. However, since we are calling our soft lock start, and we want to check to see if we are locking onto a target, otherwise we don't want to run this event. So off of false, we can make sure that is this timer currently running, or if our target locked is true, then we run this event. So now when we press tab, we'll switch the targets. So if we are target locked onto our first actor and we move within range of the other actor and we can tab at any time, you'll see that our focus switches between the two actors. Now, one thing we may notice is that if you start the level and you don't move at all, you'll find that our line of sight is still focusing. That is because if we don't move, we don't actually start our moving. So we want to make sure that moving is set off by default if it's not. Again, recall we set this in our action input move in part 3. So now when we press tab, we are no longer automatically rotating the camera's rotation until we are actually moving. Now I'm going to go through and test this out by dragging out a couple enemies and populating it around the level. So now if we start our hard lock and we reposition ourselves, we're able to tab across every actor that is viable in our array. But one issue that we have is that when we try to tab target while we aren't facing these actors, we're still able to target actors that are not on the screen. So to fix this, we could go up to our soft lock start and we can clear the array whenever we call this, but because this is working perfectly fine for our soft lock, we're gonna go over to the tab targeting, and before we call soft lock start, we're going to clear the targeted actors array. So now when we test this out, we're only getting actors that are on the screen. But one last issue is that if we try to tab target to an actor that is on the screen, but our currently locked on actor is not, we're not able to move the position. This is because when we have our target actor length, we set it to greater than 1. Now we can set it to be greater than 0, or you can also say is not empty, up to you. But now when we change that and we clear our array, we should have no issues of locking on to an actor. Just gonna go over, lock on this actor, turn the camera over, and now when we tap target, it immediately goes to the only viable actor on screen, and no matter how many times we press it, we're not able to move it to any other actor because there's nothing else to lock onto. Back since this soft lock start and clear is the same event again as what we call in our top loop for our soft lock loop. I'm going to call it here. And now since this is doing considerably more than just getting the soft lock loop, we're going to rename the event. And we'll just call it update actors. Or maybe update target actors, again, up to you. Now, one other quirk of behavior that I just want to highlight is that if we start tab targeting through things, you'll notice it went from our rightmost mannequin to the furthest mannequin to our leftmost mannequin, and then it starts going in an actual rotation. This is because when we do a multi-sphere trace, it doesn't necessarily get the closest actor every time. Like if I were to go roughly right next to this mannequin and start, then yes, it will get the closest. And if we add in this other mannequin to the right, it is closer, so it will be the next one. And so we're going to make a simple sorting algorithm to have our actors sorted by its distance from the player character. So we can just create a new function and we'll call it sort by distance. And we'll have one input, which is going to be an array of actors. We'll just call it actor array or something to that effect. And so we're going to get a for each loop. And then we're going to get a for loop. Our first index is going to be the array index of our first for loop. And the last index is going to be our array's last index. And we can just make a reroute node because we need to get a get copy. And the copy is going to be the index of our for loop. Then we're going to get distance 2. And we're going to duplicate it. We're going to take the array element of our for each loop, and that is going to be our other actor. And our other actor for the first distance 2 is going to be our get value. Then we're going to compare these two. So if the first get distance 2 is less than the second, put a branch. And then we're going to get our array. We're going to call swap. The first index is going to be the index of our for loop. And the second index is going to be the index of our for each loop. So now for every item in the array, we loop it against every item that is in the array to check to see if its current distance is less than the other actors in the array. And then we keep doing that until we have a sorted array of actors from the closest to the farthest. So now we can place this right after we get the array off of our completed. So we'll get sort by distance. And then we call the targeted actors array. Now when we test it out, we are not bouncing back and forth between any other actors, and we are still able to get the nearest actor in the array. And now that we have an actual sorting algorithm, it pretty much performs the same function as our get nearest target. And since we got rid of the variable in the last video for our nearest distance and replaced that with something else, if we go into our nearest target, the only thing that this does differently really is now just closing out the soft lock widget on our actors. So if we copy the soft lock widget, go back to our event graph, we can effectively remove the timer portion. So whatever our selected target is, we set it to be hidden. Then we take our targeted actors, and now we can get a copy. And leave the index at 0 since the first in our array is going to be our closest actor. And now we can paste our selected actor and set it to be our copies of index 0. And then we can turn on our soft lock widget. We'll get to the hard lock portion in just a second. This to be visible. And now when we wander up to our mannequins, we only have the closest actor. So now that this has been rendered redundant, we can remove this event. We can remove the get nearest target. And we can get rid of the timer and the timer handle. We'll get our branch with our target locked. And we'll do all of this stuff with the selected target only if we are no longer locking onto a target.
So now we have a pretty functional hard lock and soft lock system, and in the future I'll be going through a number of ways to make good use of it. Motion warping animations to target locked on enemies, getting enemy information like name and health values to show up on the player HUD when an actor is targeted, and probably a few more things I can think of. But for now, I just wanted to say thank you to the patrons who have supported me, and a special shout out to the Pillars, Winterberry Shark, Thatcher Moss, and Francesco Pota. And of course, thank you for watching this video, and as always, I hope you've been inspired.